Section 10, Panel Array. Once you've drawn your paneling area using one of the two methods we looked at previously, you can use AutoCAD tools to create, let's say, a rectangle panel here. We'll do dimensions of 36 by 24, and then we're going to use the AutoCAD Array tool in order to array this rectangularly. We can specify how many panels we want going downward. Also our spacing down here at the bottom in CAD, we'll say that we'll do 36.5 to get a half-inch panel gap in our columns, and then we'll repeat the same for our rows. So 24.5. And since that went in a positive direction, we'll just drag this downward here. We'll drag this over just one more row to the right, and then we'll just hit spacebar to complete the array. I'll explode that, and then we can extrude these guys to create AutoCAD solids. So we'll just extrude, and we'll say our panels are 2 inches in depth. We'll go to the top view, and we can then start slicing, just using the AutoCAD slice now to specify the extents of the panel here. So I slice there, and it creates this 3D slice where I can chop off a portion of the panel. And just keep repeating slice. And then we can remove this portion that's inside of the wall. We can then union, just using AutoCAD union, those two pieces together. So we have this one very custom 3D panel going on there. And then you can repeat those same tools in order to make modifications to the rest of the panels. Section 11, Surface Analysis. Starting by fitting a plane to our wall surface here, we will follow that by using the planar analysis tool on the modeling panel in order to get different analysis results. We're going to use the cubic plane that we just created by hitting select plane, and then we're going to set up our parameters, which determines the quality of our results. Maximum point cloud distance we'll set to unlimited since we've done some good clipping. We'll specify an X and Y direction based on how often we want to get a sample point. So I have a 1 foot by 1 foot grid, or 12 by 12 here, and each grid I want to get an average point. I'll click OK. I'm going to leave the box to interpolate unchecked. That way where I have gaps I actually get no data there. And on the right I'll check the polyline grid with deviation result and point cloud result. The result of the polyline grid with deviations is what you see in this drawing. So those values that are in purple are above the plane, those that are in red are beneath the plane, and that can tell us, how the wall is sitting in comparison to ground, and also with respect to the plane. The last drawing that we have here is the point cloud result. This creates a sort of heat map colorization of the point cloud that we can tell how the wall is deviated from the plane, and we have a legend here on the right. This is a great communication tool with those in the field, internal and external customers, to help see the wall deviation.